Hello everyone, thank you for joining me today. I wanted to make a quick video talking about a interview problem that kind of eluded me for a long time. I was just scared about getting presented with this during the interview, especially when I was a student at the boot camp and in my early days of learning uh, algorithms. And that question is permutations. Now, there are a lot of solutions out there. There are really a lot of elegant solutions, some really efficient ones. I'm not really worried about those for the answer today. What I want to do is show an answer that is easily digestible for those of you who maybe also have a problem with it, or new learners and people new to this industry. This is something that I think, and this is kind of opinionated because you might find one online that more resonates with you, but this is a solution to me that is very straightforward and easily to digest. Now, if you are new to, if you don't have good knowledge on recursion or functions, or for that matter, arrays or strings, then this probably won't be something that's easily digestible for you. But if you have at least a base knowledge of that, then stick along, see what you know, and write this down, copy this down, and see how this works. Hopefully I code everything correctly. So let me show you what I mean by permutations. So given a string of something like this, let me actually write that just a little bit bigger. A, B, and C. Can you guys see that? Yeah. What you want to do is find all the permutations of this. So this should give us, I think, 6 answers. So it should be A, C, B. A, B, C will be one of the answers. We would have B, A, C, B, C, A. And then we'd have C, B, A, and C, A, B. I think that's it. So we'll end up with 6 answers off of this 3-letter string. If we did 4, I think we'd have like 24. So you can do the math on that. I think it's factorial. But you guys, if you notice that we have some similarities here. And one thing that you'll notice is that we have the same reoccurring subproblem where we could swap these 2 characters and then end up swapping this A along the way. And how we're going to do this problem is actually just like that. What we're going to do is build a recursive problem. Actually, I'm going to rewrite this up here. That does the following. What we're going to do is, given this string, we're going to break the first character of the string off of this entire string. So what we're going to be left with is A and B, C, 2 separate strings. But then what we're going to do with this string is break it down to its furthest properties too. So, and what you'll notice here, and this will be very clear once we get down to the bottom, we're going to break this down to B and C. Okay? And what we're going to be left with is this single character that we don't really need to break it down and send it to its own function call. But we could, we might do it in our problem. But what we're going to do is turn this single character, once we see a single character, we're going to turn that into an array. And then what we're going to do to, using this and using a new array, is we're going to start pushing all the possibilities that B and C could make. Now, we're not worried about A yet, and if we have more characters, we wouldn't worry about that. We go down to the smallest subproblem that we can get to, and then kind of bubble back up. So what we'd have, if you notice here, B can go in 2 different spots. It can go, I'm just going to use this as an example, but we would have another array in our call. We would have B and C in this array, and we could have C and B. Now, there are no more combinations that we can make here. So what we're going to do is send this back to A and let A make all of its possible combinations with these two strings. So given that, if we rewrote that up here, I'm going to rewrite this just a little bit bigger so you guys can see. A, and then we have B and C. And I don't know if they're in the right order. I don't know if I wrote it this way. Hopefully I did. C and B. A will make its new array, make a new array, and it will start looking at one string at a time. And it will start making its positions of each one. So it would say, hey, I can go in the first position, middle, and end of this one. I can go in the first, middle, and end of this string as well. So it'll do that. So giving this one, we're going to look at one of these at a time. So we're going to say we have A, B, C. We can make B, A, C, then B, C, and A. So that gives us all of our combinations for our first one. But now we're going to do it off of this one as well. So we'll do, this one will be A, C, B. Hopefully you guys can all see that. Hopefully I don't drag off to the screen too much. A, C, B, C, A, B, C, B, A. With that, we've done all our possible permutations. If we had another letter in front of A, we send this array back to it and let it make all the possible combinations off of each word here. Now again, not probably the most efficient thing that we could be doing to build up our subproblems, but a very good and digestible way to solve this problem. So now we're pretty much done. This would be our answer. You see, this follows our suit. Now, so how do we do this? Well, now that we have this in like pretty much layman's term, we've pretty much coded this out like physically, even without code. Let's talk about what we did once more. So what we did was, given the whole string, we took off the first character of the string and separated it from the rest of the characters. Then we took the rest of those characters, kind of broke them down to we did the same thing to them. We took the first character of that, broke it down, until we got to the smallest problem, one character and pretty much one character. And then we started bubbling back up, building all permutations of that subproblem. That's pretty much the answer. So how would that look like in code? Well, something like this. Let's do function get perms. And this function will take in a string. Okay, and again, I know there's some things we could do to make this a little bit more efficient. What I would do if I wanted to make this a little bit more efficient than I'm going to write it is actually check to see if this is an array at first. If it's not, change it to an array. So that way we don't have to recombine a string every time and do unnecessary things. But I'm not worried about that. I'm really worried about like the readability of this. But what we will do, like all recursive functions, we need a base case. This base case for this problem, the way I'm going to write it, will come right in the beginning. And it will be the same as what we did in our diagram. We need to get a string that's one length, right? Like, and then we start building subproblems off of that and start bubbling back up. So that's what we're going to check for here. If string dot length less than or equal to 1, return. And then here's the neat part. What we're going to do here is return an array of that character. And we're going to make that an array. We're doing that on one line, just make it a little bit cleaner. But if string is less than or equal to 1, return string. So what would happen here if somebody passed in a string that has no length, like an empty string, like something like this, this would just return right away. Like there's no permutations you can make off of that, right? But if there's, I'm going to move this up just a tad so we can see this just a little bit better. Perfect. So yeah, if they send an empty string, it will return. But now if they have one character that they just pass a string, it will return to them like, hey, here's the permutation of that one string. But if we've made other function calls of that, it will return back to the function that called it and start building. We can start manipulating that string. So what we're going to do, if that's not the case, what we're going to do is do var first. And this will be a variable that stores just our first character. We're going to say equals string of 0. And again, this just grabs the first character in that string. Okay? And then what we're going to do is say var rest, and this will be the variable, just like we said, the rest of our string equals string slice. And we're going to slice from first. So grab everything from index position 1 and on, leave out the first character. Okay? And then what we're going to do is say var perms. So this will be an array of all the possible problems with our rest of our string. This right here, we're going to say equals get perms. We're going to pass it rest. So again, this would be like in the first solution, A, B, and C. We chopped off the first letter. Rest would be B and C. And then we're going to send the rest of that string to this function and let it come back after it solves its subproblems. Okay? So var perms equals get perms with rest. Okay. So down here, what we're going to do now is after we get all this stuff, well, once it gets to its bottom case, we're going to need to start doing what we did to our string, going through that subproblem, putting the first character in every position of each string that it can go. So what we're going to do is say, first we're going to make a var, let's see, what should we call this? Let's call this our made perms. And this will be an array of all the perms we made within this function. So as you see here, starts off with an empty array. We're going to start pushing our characters in there. And we're going to base it off of this array that came back from this function. So we're going to say for, and then we're going to say word of perms. So each word in there might be only one. There might be a plethora. Doesn't matter. We'll just go through them one at a time. And the reason I'm using this, just this laziness, really, I don't want to retype this. I don't want to type a var I. You could do that if you want, but this just grabs using word of or any key and of. Grab the actual word in this thing instead of just grabbing an index position. So we don't have to write. It shortens our writing down a little bit. So for word of perms, what we're going to do is now I will need to do this because it just makes sense to me. You don't have to. We could do car in if we wanted to, but I'm going to write another loop here. We're going to do var I equals 0. I is less than word dot length. I plus plus. Okay? Cool. And here's where we're going to build our word. We're going to say made perms. So now we're going to start pushing it to the array, like I said earlier. Made perms dot push. We're going to push into that array, and then we're going to say word dot slice 0 up to I. Oh, and I made one mistake. What we're going to do is go to word length here, just to make sure we can push the character to the end of the length. If you don't do that, you won't be able to push the character to the end of the word. But we'll say word dot slice I plus the first character plus, still on the board? Cool. And then we'll say word dot slice 1. Make sure I grab everything. Cool. Sorry about my little sloppy writing. All right, so that's that pretty much. Boom, boom. And then what we're going to do is return this, all the permutations we made back to the function that called us. So we'll say return made perms. So all the perms we made. And there we have it. There's our function. So try to code this out. See if you can understand this. One thing that helps me, if it's still a little bit foggy, is to, as you go through this, comment under each line what each line is supposed to be doing. So like how I explained it in this video, like make a comment line and say what this is supposed to do as you're writing the code, you'll notice that it will start coming. So here's the function. Hope you guys enjoy it. Let me know if you have any questions.